The following questions are all from day 45 and 46 from pages 83 to 85 in the textbook. So all of the questions right before that checkpoint number 1. The first question that I'm going to be talking about is 2g. All you have to do is find the derivative of this function. So before I even try and find the derivative of this function, I am going to rewrite it just so that it looks a little bit easier for us to see. So since this x is in my denominator, and I know that it has like this imaginary power 1 right here, I can rewrite this as y is equal to 5 times x to the minus 1. So you're going to have to dig deep and think back to those exponent rules where if something is in the denominator, we can rewrite it in the numerator with a negative exponent. At this point, we can start doing the derivative. So dy by dx is equal to, and then we're going to use the rules that we were talking about in this chapter. So we're going to take that exponent, multiply by the coefficient out front, and we're going to get negative 5x, and then our new exponent is going to be 1 less than the original, so a negative 2. Now I can rewrite this. I'm going to keep my coefficient in my numerator, and then this x to the negative 2, I'm going to rewrite in my denominator as a positive exponent. The next question I'm going to be talking about is y is equal to 4 over root x. Now again, I'm going to be rewriting this. So y is equal to 4 times, and I'm going to rewrite this denominator in my numerator, so I'm going to have x to the negative 1/2. So the square root of x can be rewritten as x to the 1/2, but again, since it's in the denominator, I'm going to rewrite it in my numerator as a negative. At this point, I can do my derivative. So I'm going to do my negative 1/2 times my 4, so I will get negative 2, and then x to the power of negative 1/2 take away 1, so a negative 3 over 2. Now, I can just do this on the side. If I have negative 1/2 and I need to take away 1, that's the exact same as negative 1/2 take away 2 over 2, which is negative 3 over 2. And then I can go ahead and simplify this a little bit more. So I'll keep that negative 2 in my numerator. My new denominator, since this is a negative exponent, is going to be x to the positive 3 over 2, which I can rewrite a little bit more as the square root of x cubed. Now again, if you forget this exponent rule, the denominator in my exponent is what tells me that this is just a square root. Technically, there's a little 2 out front here. We just don't write that. If there's nothing there, we assume it's a square root. And then the numerator in the exponent is the exponent of the x here. So for example, if this denominator was a 4, if it was x to the 3 over 4, there would be a little 4 in front of this root, so it would be the 4th root. So this is the final answer for 2h. Alright, question 3c says, determine the slope of the tangent to the graph of each function at the indicated value. So my function is here, g of x is equal to negative 3 over root x. So I'm going to go ahead and rewrite that before I try and do anything. So negative 3, and again, this denominator of root x is going to move to the numerator and become a negative exponent. I can take the derivative now, so I will have this negative 3 times this negative 1/2, so I'll get a positive 3/2 x to the negative 3 over 2. Again, this negative 1/2 take away 1. And I can rewrite this, so I'll keep the 3 in my numerator, the 2 will go in my denominator, and this x to the negative 3/2 is going to go in my denominator as a positive exponent. And I can rewrite this a little bit. So again, x to the 3/2 is the square root of x cubed. What I'm going to do now is think about this. So this, what I have right here, this g prime of x, this is the equation of the tangent. The question asks me for the equation of the tangent at x equals 4. So, the slope of the tangent at x equals 4. So I'm going to take the x equals 4 and plug that into the equation of the tangent. So g prime of 4 is equal to 3 over 2 times the square root of 4 cubed, which equals 3 over 2. The square root of 4 is 2, so times 2 cubed, which is equal to 3 over 16. Question 20 says, determine the slope of the tangent to the curve f of x is equal to negative 2x cubed plus 5x squared minus x plus 3 at x equals 2. So the first thing that I'm going to do is find the derivative. So f prime of x is equal to negative 6x squared plus 10x minus 1. And then, of course, I'm going to plug in that x equals 2. So f prime of 2 is equal to negative 6 times 2 squared plus 10 times 2 minus 1. Negative 6 times 4 plus 20 minus 1. Negative 24 plus 20 minus 1, negative 5. Now, I needed to do this in order to do part B. So in part 1, we found the slope of the tangent at x equals 2. The part B says they want the equation for the normal at x equals 2. So if you looked at the question, they gave you a little diagram, and I'm just going to kind of explain it right now. The tangent and the normal meet at a 90-degree angle. And so if the slope at x equals, the slope of the tangent at x equals 2 was negative 5, then that means that the slope, oh, sorry, I'm not writing here, that the slope of the normal is going to be the perpendicular slope of that. So instead of negative 5, it's going to be 1 over 5. Now, if you don't know why m is equal to negative 5, that means that m perp is going to be the flip of this and the opposite sign. So that kind of will explain how I got this. And then at this point, I'm going to plug 2 into my original equation. And the reason I'm doing this is because in order to find the equation, I need the y, the x, and the m. That's the only way that I'm going to be able to find my y-intercept. And so I need to find f of 2. Not f prime of 2. I don't care about the slope at that point. I just want to know the point on the original graph where x is equal to 2. So f of 2 is equal to negative 2 times 2 cubed plus 5 times 2 squared minus 2 plus 3. And that's going to be equal to 5. So I know that on the original graph, I have the point of 2, 5. So now that I know this, I know my m, I know my x, I know my y, and I can plug that into y equals mx plus b. So 5 is equal to 1/5 times 2 plus b. 5 is equal to 2/5 plus b, which means that b is equal to 23 over 5, or 4.6. Make that a little bit smaller for you there. And then, now that I know all of this, I know that my equation is y equals 1/5 x plus 4.6, or 0.2x plus 4.6. All right, so the last question, 21a. Find the slope of the tangent to the curve f of x is equal to negative 4x cubed plus 3 over x plus root x, subtract 2 at x equals 1. So just like with these beginning questions, I am going to rewrite f of x. I'm not going to even try and take the derivative yet. So I'm going to rewrite it as negative 4x cubed, and then instead of 3 over x, I'm going to say 3 times x to the negative 1. Instead of root x, I'm going to say x to the 1/2. And now that I have that rewritten, I can go ahead and start taking the derivative. So negative 12x squared minus 3 times x to the negative 2 plus 1/2 x to the negative 1/2. And I can rewrite this just to be a little bit nicer as minus 3 over x squared. So move that negative exponent into my denominator, plus 1 over 2 and then that x to the negative a half is going to go in the denominator as a root x. Now, at this point, now that I have my derivative, I can plug in my x of 1. So f prime of 1 is equal to negative 12 times 1 squared minus 3 over 1 squared plus 1 over 2 times root 1, which is going to equal negative 12 minus 3 plus a half, which equals negative 29 over 2. If you're still having some issues with any of these, or you just have any quick questions, absolutely send me an email or an instant message and I will gladly explain a little bit further.